In this video, I'm going to demo the Flutter app for Bluetooth. So I have the Flutter app running in my computer, and the Android device is connected through a wired connection. Here, as you can see, it is connected through a wired connection to the computer. Now my main app, so this is the connection app, and here it will establish a connection with the Raspberry Pi 4. So I have used the Flutter Bluetooth serial package here, and the Bluetooth connections are done here. So here there is a connect method, and then there is a received there is a send data, and then there is a received stream method. So and then there is disconnect and dispose of the connections. So I'm calling this Bluetooth package in my main file here. So main file will have it will connect to the device. This is the Raspberry Pi MAC address, and then it will call the send data function here on press. Like there are three buttons created. One is this is the main widget function, and here there are three buttons created. One is the connect, another is power level, and then another is disconnect. So it will first connect to the Bluetooth device, then it will ask the power level, and it will disconnect at the end. So let me show you the app actually what it looks like. So this is this is the Bluetooth serial communication app, and if you see, like we have this connect button. When I press the connect button, here it will as you see that it is saying that it is already connected, and then if I send a power level, press, and then if I press the power level here, it will actually, let me put it here. So once I press the power level, it will show the power level here. So now I press the power level, so it shows that data sent is power level, and data received is 7.64, and it is also displaying in the app 7.64. And now this is the Raspberry Pi. If you see here, this is the program inside the Raspberry Pi, which imports the PyCar library, and then gets the power from there. And this is the Bluetooth RFCOM function, and if you can see that it has received power level, and as per the request it also send out the data to the app. Thank you.
The web service creation section has mainly two components. One is the server-side component, another is the client-side component. In the client-side component, we have main three modules. One is index.html, index.js, and the main.js. Index.html and the main.js mainly for the interfacing, and actual communication is happening in the index.js. In the index.html module, we are calling the module index.js, and we are also sending the instruction to control the car from here, from this section. And we are also displaying the car's statistics over here. That includes the GPU temperature, CPU temperature, CPU usage, battery information, disk usage, and RAM usage, and the speed and the distance traveled by the car. In the index.js, we are having the server address with associated port number through which we will be connecting to the server from here. That's been from the client machine. Here we are creating a WebSocket connection with the server. Once the connection is created, we will be opening that connection between the client and server. Here in this section, we are receiving the server response in this section. Here these two methods are called from the index.html module. Here in the move car function, we are sending the instruction to the server to control the car. Here in the main.js, we are using the browser window object to load the HTML page over here, and we are also mentioning the window dimension over here. In the server-side program, we have three main methods. First, the get parameter methods. In the get parameter methods, we are getting the different status of the Raspberry Pi, like the CPU temperature, CPU usage, GPU temperature, battery status, disk usage, and the RAM status. In the move piker method, we are getting the instruction from the client side in the direction parameter, and we are moving the car according to the instruction in this method. In the handle message method, we are preparing the response message that will be sent to the client machine and for the display in the dashboard. And here we are keeping the host as 0. That means we can that server can listen from the any of the client machine with the port 65/32. Starting the server side program. Yeah, it started and it's listening through port 65432. Now I'm starting the client side program. So here is the dashboard. In the dashboard we have forward button, right turn button, left turn button, backward button, and the stop button to control the Pi car. And here we have the information to be displayed about the CPU temperature, GPU temperature, CPU usage, battery, disk status, RAM status, and the speed of the car. Now I'm giving the move forward instruction. Upon press, it is started moving forward. Now I'm stopping the car. The car has stopped. Now you can see the status of the Raspberry Pi over here. At that time we have the CPU temperature of 41°.87 degrees Celsius. The CPU usage is 1.51%, and the distance traveled before stop the car is 578 centimeter. Now again I am giving the instruction to move backward. The car started moving back. Now I'm stopping the car. Stop the car, and the distance traveled by the car is updated over here. Now I am giving the right turn instruction. Yeah, the car started running. I'm stopping the car now. The left instruction, I am giving the left turn instruction now. Yeah, it started turning left with the speed of 5. I am giving the stop instruction to stop the car. The car has stopped.